In this question, we're being asked to find the limit as x approaches 2 of this function, where we have like fractions over fractions. So first thing we should do is just see, can we sub in 2 in place of x and just find the limit directly? Because if we don't end up with a 0 over 0 scenario, then we can just sub it in. So let's try that first. So let's write this now as 1 over 2 minus a half over, and then on the bottom here, if I sub a 2 in for that one, we have 2 minus 2. So yes, that is in fact 0 over 0, which is in an indeterminate state. So we have to do some reconfiguring here if we're going to be able to find the limit. So let's try a different approach. So for the most part, what we want to do is we just want to cancel something, right? And I'm looking at that x minus 2. It's probably going to be that one in the end. But yeah, so you'll know you probably did it right if we end up canceling something in the process here. So let's take a look at the top part here of this fraction. So what we can do here is we could write this over a common denominator of 2x. So let's try that. And quite often when you get a fraction over a fraction, that's going to be the process. So if I was going to write this over a common denominator, I'd have to multiply this side by 2, top and bottom, and I'd have to multiply this side by x, top and bottom. So what we'd end up with is 2 minus x over, and then our common denominator was 2x. And then that was all over x minus 2. Now, I've got fractions over fractions. It gets a little bit confusing. I like to put this top part in brackets just so I can like think about that as like, one thing. So, okay, so there you go on that one. Now, we're getting close, right? X minus 2 on the bottom, 2 minus x on the top. That's not quite right. So what we can do there is we can actually factor out a negative, and then that'll turn into the same, and then we'll be on the right track here. So let's do that. So I'm going to factor out a negative out of this. So this would be negative 1 if you like, or just negative. And then what's left is negative 2 plus x. Okay, over 2x. And then that was all over x minus 2. All right, if you like, we put that in brackets just so we know that that's one thing. It's getting a little messy. So, but anyway, so now what I can see is the top here, right? That piece, that is the same as that piece, right? Because negative 2 plus x is the same as x minus 2. So I just need to cancel those, right? So let's again just write this a little bit different now. So I've got negative 1, and then I'm going to write that now as instead just x minus 2, just because that's what I want it to be. And then that's over 2x, and then that's over x minus 2. Now, you might be able to see right now that you could cancel that, right? You got this in the numerator and this in the denominator. You could just cancel that. But just as a review, why that works, right, is because you can think of the denominator like that, right? So now, if you're dividing by a fraction, that's the same as multiplying by the reciprocal. So I can write this now again as negative 1 x minus 2 over 2x. And now I'm going to multiply by the reciprocal of these guys, right? So now 1 over x minus 2. 1 over x minus 2. And now it's a bit more obvious that, yeah, you can cancel those. And it's that canceling right there that probably means I'm going to be able to take the limit now, right? So now that we have this, let's clean that up a bit. Actually, I'll write the limit at this point too. So let's actually do the question. This would be the limit as x approaches 2 of, and then we'd have just negative 1 over 2x. So now we can just plug that in, right? Because if I plug in 2 here, then that's going to be negative 1 over 4. Okay, so that's just equal to negative 1 over 4.